Hello and welcome to the Exam 1 review webinar for Math 130 for Term 15 EW1. So Exam 1 is going to cover material from Module 1 and Module 2. And in your book that is sections 1.1 through 1.4 and then 2.1, 2.2, and 2.4. Just a reminder that your exam is due on Tuesday of next week, so not on Sunday like you would normally expect for most of your assignments, but you do get a couple extra days with the exam. Again, please fill out that attendance form on the side. That is the best way to make sure that this is going to be documented and that we get your information correct. Tips for taking your test. First, give yourself plenty of time. This exam should take about 2 hours. And, really don't stress yourself out if it takes you more than 2 hours. Make sure that you just keep a clear mind. It's the best way to not get flustered. Once you start to worry about things that are outside of the realm of the questions, that's when you start to have trouble. So make sure that you've set aside plenty of time for yourself to work on the exam. Take your exam in a quiet place. Turn off your TV, your phones, and any other distractions so that way you can focus on the exam and not worry about anything interrupting you. Have your notes, your textbook, and your exam study guide available to you and ready to go. It is not against the rules for you to look through your notes or your book to work on finding an answer. So go ahead and make use of those resources. Look up each question. Study similar examples. This will help you work through the exam questions quickly and accurately. By using examples that are similar, you have the ability to continually build that knowledge base, and you can apply that information later on. So the more practice you have, the better you'll do. Watch your decimals. This is a big one. Keep at least 3 to 4 more decimal places than the number they request. So if they say round to 3 decimal places, make sure you're keeping at least 6 to 7 until the final step, which is when you would round down to that final number that they're looking for. Make sure you read the directions carefully. A lot of simple errors in math problems can be handled by just rereading the question and making sure that you're answering the right thing. And most importantly, good luck. You're going to get through this. This is just the first exam. You're going to have the understanding, hopefully, of everything after this webinar, and you'll be able to get in there, use your practice as a tool, use your resources, and find that spot where you're actually starting to be able to handle the material. So, we're going to start with some vocabulary, because that's everyone's favorite. But one of the things that people have noticed, something that has been brought to my attention, is a lot of people were intrigued by the fact that the first module was a lot of just understanding vocabulary and learning the concepts, and there wasn't any real math to it. So, the definition of statistics. Statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or to answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. So it's not just about drawing conclusions from the data, but also being able to speak to that number with its some amount of confidence to say, I feel pretty confident that this is the correct way of looking at it. A statistic is a numerical summary of a sample. Descriptive statistics consist of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, or graphs. Inferential statistics uses methods that take a result from a sample, extend it to the population, and measure the reliability of the results. So you're making an inference. You're looking at a small group and applying that to the larger group. The information is data. which is a fact or proposition used to draw a conclusion or make a decision. A population is the entire group that is being studied. So the population is the big piece. And then a sample is a subset of the population that is being studied. So you have population is the biggest, sample is a small group within the population, and then an individual is a person or an object that is a member of the population being studied. So in order of size, population is the biggest, a sample is a small group of people within the population, and an individual is a single unit within definitely the population and sometimes within that sample. A parameter is a numerical summary of a population. All right. Variables are the characteristics of the individuals within the population. So they're the things that change. They vary. That's what a variable is. It's something that is capable of changing. There are a few different kinds. So qualitative, or sometimes it's referred to as categorical variables, allow for classification of individuals based on some attribute or characteristic. Quantitative variables provide numerical measures of individuals. The value of a quantitative variable can be added or subtracted to provide meaningful results. A discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. The term countable means that the values result from counting, such as 0, 1, 2, 3, and so on. A discrete variable cannot take on every possible value between any two possible values. So discrete means it's specific. It's a very narrow amount that is being measured. A continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. A continuous variable may take on every possible value between any two values. So a continuous variable is something more like a measurement. So time, distance, things like that are continuous because you can keep breaking it down into smaller and smaller pieces and get more pieces smaller and smaller and smaller and smaller, but it never really stops. You can extend those decimal points out for very, very long periods of time. So an explanatory variable is a variable that explains what is happening. So when you have two particular pieces of data, you have the explanatory variable is telling you which one is the cause of the other. A lurking variable, a response variable is the variable that is directly being affected by the explanatory variable. So when you have some item that's affecting another item, the explanatory is the one that is doing the affecting, and the response is the one that is being affected. A lurking variable is an explanatory variable that was not considered in a study, but that affects the value of the response variable in the study. In addition, lurking variables are typically related to explanatory variables considered in the study. So that's something where you're going to see an item that you didn't consider is affecting the outcome of your experiment. That is a lurking variable. In terms of the levels of measurement, so there are 4 levels of measurement, and they break down like this. So a variable is at the nominal level of measurement if the values of the variable name, label, or categorize. In addition, the naming scheme does not allow for the values of the variables to be arranged in a ranked or specific order. So these are things where we've got a specific category that they fall into, but we can't organize them within that category. A variable is at the ordinal level of measurement if it has the properties of the nominal level of measurement. However, the naming scheme allows for the values of the variable to be arranged in a ranked or specific order. So nominal as in name, ordinal as in order. So the first set of variables can be named. Beyond that, you have ordinal level, they can be ordered. A variable is at the interval level of measurement if it has the properties of the ordinal level of measurement, so it can be organized, and the differences in the values of the variable have meaning. A value of 0 does not mean the absence of the quantity. Arithmetic operations such as addition and subtraction can be performed on the values of the variable. So if it's at an interval value, you can add and subtract the numbers of the variable and get meaningful results. A variable is at the ratio level of measurement if it has the properties of the interval level of measurement and the ratios of the values of the variable have meaning. A value of 0 means the absence of the quantity. Arithmetic operations such as multiplication and division can be performed on the values of the variable. So ratio means that you have something that is able to be multiplied or divided and it still has meaning. And we'll get to some examples of those here in a little bit. An observational study measures the value of the response variable without attempting to influence the value of either the response or explanatory variables. That is, in an observational study, the researcher observes the behavior of the individuals without trying to influence the outcome of the study. So this is where you would see the stereotypical experiment where someone is watching through a piece of double-sided glass so they can see how the person behaves in a certain environment. They're observing them. If a researcher assigns the individuals in a study to a certain group, intentionally changes the value of an explanatory variable, and then records the value of the response variable for each group, the study is a designed experiment. So this is something where you set people in a room, but this room has no chairs. How do the people react to that situation versus the people who are in a room that have chairs? Confounding in a study occurs when the effects of two or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response variable may be due to some other variable or variables not accounted for in the study. So this is when you have those lurking variables, they can kind of muddle up the outcome because you weren't anticipating it. So it's not necessarily the variable that you were looking at as the explanatory variable influencing the outcome of the response variable. A census is a list of all individuals in a population along with certain characteristics of each individual. And I feel like most people are pretty familiar with the idea of a census. It gains the information of all of the people in an area. So, sampling is the act of pulling individuals out of the population into a sample. So, random sampling is the process of using chance to select individuals from a population to be included in the sample. And, a little bit more above that is the idea of a simple random sample. So a sample size n from a population of size capital N, so little n for the sample, big N for the population, is obtained through simple random sampling if every possible sample of size little n has an equally likely chance of occurring. The sample is then called a simple random sample. So that is the best possible way to have a random sample, is if there's an even chance that any particular sample could be drawn from the same population. A stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. the individuals within each stratum should be homogeneous or similar in some way. So that would be like separating groups of men and women, separating people by their age, separating people by the towns they live in. You're breaking them up into a specific non-overlapping group and then pulling samples from those individual groups. A systematic sample is obtained by selecting every kth individual from a population. The first individual selected corresponds to a random number between 1 and k. So, you're standing outside of a line and you're like, okay, I'm going to select every fourth person. So people start walking in. 1, 2, 3, 4, you pick the person. 8 is next, then 12, then 16. It's systematic because there's a system behind it. It's not random because you're specifically picking people at that interval. A cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. So this is taking and grouping people into groups and then saying, okay, I want to study this specific group within the population. So that would be like looking at just one individual strata without breaking it into simple groups. So the idea of replacement means that you can select someone from the population for your sample, and then they go back into the pool where they could potentially be drawn again. So a way to kind of think of this would be almost like if you think about how they draw lotto numbers, where the balls all bounce around and one ball pops up. So that's non-replacement because they draw one ball at a time and the ball stays out. If there was replacement, they would pop one ball out and be like, oh, it's number 12. And then they drop the ball back in and they pull another ball, and there's a chance that they could pull that number 12 again. So that's how replacement works. So, a frequency distribution lists each category of data and the number of occurrences for each category of data. So you have a classroom of children and you want to know what the most popular name is. So you mark down 1 for every Jennifer, 1 for every Tamara, 1 for every Stephen, 1 for every Jonathan, and you tally up the number of those individual occurrences. So let's say there's 3 Jonathans in a class of 15, then we know that 3 out of 15, that's the frequency. 3 is the frequency within that class of a student being named Jonathan. So you can look at it as Jonathan would have a relative frequency of 3 over 15. So the relative frequency is the proportion or percent of observations within a category and is found using the formula where the relative frequency is equal to the frequency of the occurrence, which in our example was 3, divided by the sum of all frequencies, which for a 15-student class was 15. And a relative frequency distribution lists each category of data together with the relative frequency. So a bar graph is constructed by labeling each category of data on either the horizontal or vertical axis and the frequency or relative frequency of that category on the other axis. Rectangles of equal width are drawn for each category. The height of each rectangle represents the category's frequency or relative frequency. So everything is separated into individual pieces, and the bar is as tall or as long as the number of occurrences. A Pareto chart is a bar graph whose bars are drawn in decreasing order of frequency or relative frequency. So that means you start with the largest and work your way towards the smallest. A pie chart is a circle divided into sectors. Each sector represents a category of data, and the area of each sector is proportional to the frequency of the category. And the important thing to remember about pie charts is they break into a percentage, and the total of the percentages has to equal 100% in a pie chart. If they don't equal 100%, then the pie chart is not valid. Alright, so a histogram. A histogram is constructed by drawing rectangles for each class of data. The height of each rectangle is the frequency or relative frequency of the class. The width of each rectangle is the same, and the rectangles touch each other. So in a histogram, unlike a bar graph, each bar represents an individual type of occurrence. In a histogram, it's a continuous thing where it's broken into classes of equal width. So each bar is the same width, and then the number of occurrences within that particular width is the height of that bar. So a class limit, there are two types. So there are lower class limits, which is the smallest value within the class, and there's an upper class limit, which is the largest value in the class. So if, our values go from 1 to 100, and we're going to break them up into 10 different groups, so we've got 1 to 10, 11 to 20, 21 to 30, so on and so forth. And then, to determine the class width, it's the difference between consecutive lower class limits. So the width of the first class would be taking 11, which is the lower limit of the second class, minus 1, which is the lower limit of the first class. You subtract them, and you get 10. The width is 10, and it's going to be 10 for all of those, because if you take 21 minus 11, it's 10. 31 minus 21, it's 10. So a stem and leaf plot is another way to represent quantitative data graphically. In a stem and leaf plot, or stem plot, we use the digits to the left of the rightmost digit to form the stem. So if, for example, we're looking at percentages, we would start with the numbers that are all the same. So it would start with 1%, 2%, 3%, 4%. All of those numbers, 1, 2, 3, 4, 5, 6, would be on the left in front of a line. And then to the right of that line is going to be all of the leafs, which are going to be the decimal points. So 1.0, so it would be 1 on one side and 0 on the other. And then we have 2.1, so it would be 2 on the left, 1 on the right. To get a better idea of what that looks like, you can see a picture of it on page 89 in your text. It's kind of hard to describe a stem leaf plot without taking a look at it, so I definitely recommend looking that up. So for distributions, so we have a few different types of distributions. So you have a uniform distribution, which means that the bars for the histogram are all the same height. So it's a straight line across the top of all of the bars of your histogram. A bell-shaped histogram occurs when the highest frequency occurs in the middle, and then the frequencies tail off to either side. So you can draw a bell shape over it where the highest point is directly in the middle. A skewed right graph, a histogram that's skewed to the right, will have most of the data on the left and a tail that tapers off to the right. So that usually implies that there is some higher number that is offsetting the distribution. And then skewed left is the exact opposite. Most of the data is to the right, with a tail that tapers to the left, which means there are some low values that are offsetting. And then misleading graphical representations. So what you'll see, this happens a lot in popular reading things, magazines, newspapers. You'll see a graph where it's not really a bar, or the percentages don't add up to 100%. So they'll use pictures that don't really show measurement. The numbers might not be placed correctly. So if you see a graph and the bottom of one of the values doesn't start at 0 but starts at a higher number, that can be misleading, because it could be that the numbers that they're showing are only maybe 400 or 500 digits apart from each other, but because they're leaving out the first 3,000 points of data from the image, you're only seeing those little bits at the top where they do seem to change drastically. So this is how you're going to use your study guide. So when you pull up the study guide, you'll see exam problem number 1, the concept, basic statistics vocabulary. Homework problem that you would find that in, Module 1, problem set 1. Number 1. Enter the Module 1 assignment in review mode, go to problem 1, click on the textbook button, scroll through the text looking for the highlighted definitions. So you'll find all of these definitions throughout your book. They'll be in a kind of green beige box, and that's how you can tell that they're a definition. It'll say definition on the left or the right, depending on which side of the page it's on. Nope, I was wrong. It's always on the left. In the left margin, it'll say definition, and the word that is being defined is usually in bold print. So we have some example problems. So feel free to type these into the chat box as you get the answer. So a list of observed values for a variable is... Sorry, Wendy, the census is actually the total information of all of the individuals in a population. The answer to this is data. A list of observed values for a variable is data. So this is a vocabulary question. It's very indicative of what those vocabulary questions are going to look like. Example problem number 2. Determine whether the variable is qualitative or quantitative. So, number 1, the number of flights leaving an airport each year. Is that quantitative or qualitative? That's right. It's quantitative because you can add and subtract the number of flights between years to determine significant results. Number 2, favorite sport. Is that qualitative or quantitative? Qualitative, that's right. That's a quality of someone that they have a favorite sport. Number 3, age. Is that qualitative or quantitative? And this is the one where people usually get tripped up. Age is actually a quantitative variable because you can add and subtract the ages between people to have a significant difference of understanding who's older, who's younger, and by how much. Number 4, telephone number. Is that qualitative or quantitative? Qualitative. A telephone number is qualitative because you can't add and subtract telephone numbers to get meaningful results. Number 5 is social security number. Is that quantitative or qualitative? 100% correct. Qualitative it is, because just like telephone numbers, you can't add and subtract social security numbers and achieve meaningful results. And here you can see quantitative, qualitative, quantitative, qualitative, qualitative. Example problem number 3. Is the random variable x discrete or continuous? So, number 1, x represents the number of quarters needed in a parking meter. Is that discrete or continuous? That's right, discrete, because you can specifically count the number of quarters needed to put in. Number 2, x represents the height above ground when skydiving. Is that a discrete variable or a continuous variable? It's a continuous variable because it's a measurement. Measurements can be continuously broken down into smaller and smaller pieces, and therefore it's never pinpointed into one exact spot. Number 3, x represents the time needed when taking an exam. Continuous, that's correct, because time, just like distance, is a measurement, and measurements are always going to be a continuous variable because you can break it down from hours to minutes to seconds to milliseconds and keep getting smaller and smaller. And then number 4, x represents the number of movie tickets needed for a family to see the movies. Discrete, that's correct, because you can count the specific number of tickets that you're going to get. Discrete, continuous, continuous, and discrete. Example problem number 4. While shopping, people are asked to perform a taste test in which they drink from 2 randomly placed unmarked cups. They are then asked which they prefer. Is this an example of an observational study or an experiment? So, in an observational study, the researcher observes the behavior of the individuals without trying to influence the outcome of the study. This is an example of an experiment because the researcher is intentionally imposing treatments on individuals in a controlled setting. Example number 5. One night a week, a family has leftovers for dinner. There are 4 people in the family and 4 possible leftover single-serving meals. The family members are Mark, Wendy, Sharon, and Jeff. The servings are tuna casserole, hamburger, salad, and salmon. Mark chooses a hamburger. Can the hamburger be chosen by another family member? Would this be an example where replacement is allowed? You're right. They can't be chosen by another family member because single servings, all of the meals are single servings, so once one person chooses the hamburger, it cannot be chosen by another, and this is an example of a scenario where replacement is not allowed. If replacement were allowed, a particular outcome can occur again. So in this particular case, the outcome can't occur again because there's only one hamburger. Problem number 6. A radio station asks its listeners to call in their opinion regarding the use of U.S. forces in peacekeeping missions. What type of sampling is used? That's right, convenience sampling. The radio station is relying on voluntary responses to obtain the sample data. Example problem number 7. The president of a guest lecture series at a university stands outside the auditorium before a lecture begins and hands every 5th person who arrives, beginning with the 3rd, a speaker evaluation, survey to be completed, and returned at the end of the program. What type of sampling is being used? I can definitely see how you could think convenience given this situation, but it is actually systematic sampling. The presider is sampling every 5th person who is attending the lecture. Example number 8. In a national survey conducted by the Center for Disease Control to determine health risk behaviors among college students, they were asked, how often do you wear a seatbelt when riding in a car driven by someone else? The results are as follows. Approximately what is the number of college students who responded most of the time? This is a little tough because it's kind of hard to see where the lines of the numbers are on those bars. And then, how many more college students responded always than responded never? So approximately what is the number of college students who responded most of the time? 1,200 students. You can see that it is a little bit below the halfway mark of that space between 1,000 and 1,500. And how many more college students responded always than never? That would be 2,500 minus 150 being 2,350. So you guys are really close. It's really hard to determine those variables sometimes on these graphs, so you want to, do your best, and you guys are doing a really good job. You got real close to those. Example problem 9. To predict future enrollment, a local school district wants to know the number of children in the district under the age of 5. 50 households in the district were sampled, and the head of household was asked to disclose the number of children under the age of 5 living in the household. The results are as follows. And you can see the box there. So they want you to construct a relative frequency distribution for the data. And then they want to know what percentage of households have 2 children under the age of 5. So to do that, you would take the number of households that have 2 children under the age of 5, which is 12, and you would divide that by the total number of all of the households, which is 50. So you would do 12 divided by 50 to give you that percentage. And then, what percentage of households have 3 or more children under the age of 5? So for that, you look at the ones that have 3 and 4. So we have 3 households in one household, added together is 4. So it's a total of 4 households out of 50. So the percentage would be 4 divided by 50. And there you can see 24%. And 8%. The relative frequency shows us in decimal what the relative frequency is, and to get that percentage, all we're doing is moving that decimal point 2 spaces to the right. Example number 10. The following data represents the fall 2009 students headcount for enrollments of all public community colleges in the state of Illinois. So, first part. How many classes? What's the number of classes? 6 is correct. Now find the upper and lower class limits. And then to find the class width, what you do, if you remember, is you take one lower class width and subtract the lower class width of the class before it. So if you picked 10,000, you would subtract 5,000, giving you 5,000 as the class width. So here you'll see 6 classes. The lower limits are 0, 5,000, 10,000, 15,000, 20,000, and 25,000. The upper limits are $49.99, $99.99, $14,999, $19,999, $24,999, and $29,999. And then the class width, you take 5,000 minus 0 is 5,000. A basketball player habitually makes 70% of her free throws. In an experiment, a researcher asks this basketball player to record the number of free throws she shoots until she misses. The experiment is repeated 50 times. The following table lists the distribution of the number of free throws attempted until a miss is recorded. So the first step would be to construct a relative frequency distribution. So for each one, what you're going to do is you're going to take it and divide it by 50. So 16 divided by 50, 11 divided by 50, 9 divided by 50. What percentage of the time did she miss on her fourth free throw? What percentage of the time did she miss first on the 10th free throw? And then they want to know what percentage of the time did she make at least 5 in a row? So, we see the percentage of time she missed on her fourth free throw was 14%. The percentage of time that she missed on the 10th free throw was 2%. And then what percentage of time did she make at least 5 in a row? Remember that at least 5 means that she made 6, 7, 8, 9, or 10. So we do 3 plus 0 plus 1 plus 0 plus 1 equals 5. 5 divided by 50 is 0.10, which is 10%. So 10% of the time, she made at least 5 free throws. So the important thing to remember here is that when it says at least 5, that's the key. That's the key word is at least 5. You're right, Lisa. It is very tricky. But that's why one of those important rules at the start was to make sure that you read the questions carefully. All right, example problem number 12. How is this graph misleading? What could be done to improve the graph? So this is misleading because it appears that the average housing price significantly increased between 1998 and 1999 when it actually only increased by about $2,000. And you guys are right. The base of the y-axis should be at 0, and that would improve the graph because then these bars would look a whole lot closer in size. So if you have not yet, please fill out the attendance form on the right-hand side of the page. And good luck. You guys can do it. I know that it's a little intimidating, especially with it being your first exam, but just remember to set aside enough time, find a nice quiet place, read your questions carefully,